안녕! Welcome to KMS. In this first video of the tricky functions series, we are going to find the equation of the tangent line to a square root function. To do that, we will use the first principle. If you are curious how we got this formula, check my other video. Alright, let's get started. Square root functions can be a bit tricky to work with, but don't worry, we will go step by step. Here's the example. We want to find the equation of the tangent line to the graph of f of x equals square root x plus 3 at x equals 1. And we will use the definition of the derivative, which is the first principle. To find the equation of the tangent line, we need two things. First, the slope of the tangent line. Second, the point of tangency, where the tangent touches the graph, like this. Let's start with the slope of the tangent line. We will use the first principle. In this case, a equals 1, so we write f prime 1 equals limit as h approaches 0, f of 1 plus h minus f of 1 over h. Let's find f of 1 plus h first. You just plug in x equals 1 plus h into the function. It means you just replace x with 1 plus h. So, f of 1 plus h equals square root 1 plus h plus 3, which is square root 4 plus h. And what about f of 1? Which is square root 1 plus 3 equals square root 4. It gives me 2. Let's plug these values into the formula. Then the slope of the tangent line is limit as h approaches 0. f of 1 plus h is square root 4 plus h. Square root 4 plus h minus f of 1 is 2. 2 over h. Now we try to plug in h equal to 0. Square root 4 plus h becomes 2. That makes the numerator 2 minus 2, which is 0. The denominator is also 0. So we get 0 over 0 type, which is an indeterminate form. That means we need to simplify the expression. To do that, we rationalize the numerator. Let's think about this. When you multiply a minus b and a plus b, we get a squared minus b squared. This is the same pattern. Square root 4 plus h minus 2 times square root 4 plus h plus 2. This is a minus b times a plus b. So it becomes square root 4 plus h squared minus 2 squared. Square root something squared is the something itself, so square root 4 plus h squared is 4 plus h minus 2 squared is 4. Plus 4 minus 4 cancel out, so it becomes just h. Let's apply the same idea to our limit expression. To rationalize the numerator, we need to multiply the conjugate to the numerator and denominator. So, we just multiply square root 4 plus h plus 2 to the top and multiply the same thing to the bottom. As you can see in the green box, square root 4 plus h minus 2 times square root 4 plus h plus 2 is equal to just h. So the expression is limit as h approaches 0, h over h square root 4 plus h plus 2. We have h in the numerator and the denominator, so we can cancel them out. The expression becomes limit as h approaches 0, 1 over square root 4 plus h plus 2. Now we plug in h equal to 0. Then it becomes 1 over square root 4 plus 2. Square root 4 is 2, so we get 1 over 2 plus 2, which is 1 over 4. That's the slope of the tangent line at x equals 1. To find the equation of the tangent line, we need two things. First, the slope of the tangent line, we found it, 1 over 4. Now, it's time to find the point of tangency, but actually, we already found it, f of 1 equals 2. So, the point of tangency is 1, 2. Let's clear some space to find the equation of the tangent line. Now, we are ready to write the equation of the tangent line. Let's use the slope-intercept form, which is y equals mx plus b. We know the slope is 1 over 4, so we write y equals 1 over 4x plus b. Let's plug in the point 1, 2 to find b. So, 2 equals 1 over 4 times 1 plus b. Move 1 over 4 to the other side. So, 2 minus 1 over 4 equals b. Then, b equals 7 over 4. Therefore, the equation of the tangent line is y equals 1 over 4x plus 7 over 4. Let's sketch a graph to help us visualize everything. The square root function only exists when the inside of the square root is greater than or equal to 0. So, let's find where it starts. Let's solve for when the inside equals 0. That will tell us where the graph starts. So, x plus 3 equals 0, then x equals minus 3. When x equals minus 3, f of minus 3 is square root minus 3 plus 3, which is 0. So, the graph starts at minus 3, 0 and passes through the point 1, 2. So, the graph looks like this. Now we add the tangent line. It touches the curve at 1, 2 like this. That's how we can find the equation of the tangent line to a square root function using the first principle. That's it for today. I hope this helped. See you in the next video. Bye!